Hello, class. This is Mr. Blackwell here. Just going to get us started for the day. As we talked about yesterday, we talked about the law of sines, and as I promised today, you'd be learning about the law of cosines. So the law of cosines is another tool we have to be able to find missing sides or missing angle measurements in a triangle. And so right, so 7.2.3 is going to talk about that. So the main objective today is for us to learn about the law of cosines. There's two main problems, problems 76 and 77, and so those will be what you want to focus on today in your work. And before you do that, though, we'll walk through a little bit of law of cosines, and that should help you out dramatically in those two problems. And so up till now, we have different tools to help us solve for missing side lengths and angle measurements. We have the Pythagorean theorem. Right, so a squared plus b squared equals c squared. We have our SOHCAHTOA, and now we just yesterday we got the law of sines, and so now we're going to be focusing on the law of cosines. Law of cosines really help us out when we have some triangles like this, where we may have three sides but no angles, or we maybe have two sides with an angle in between them, because at this point we don't have a way to solve for them. And so, generically speaking, if we have a triangle, and let's call this triangle ABC, so A, B, C, right, we'll label our sides A, B, C. And in this triangle, just like we did in the law of sines, I'm going to drop in a perpendicular line here, so we have a 90-degree angle, so we've got two 90-degree triangles now. And what I will do is I'll call this height, and I'll call this X, and because so I'll call this section X, and so because this section is X, I'll call this section B minus X, since this whole thing is B, but we're minusing X from it, gives us that the length there. So now there's some different things we can do here. One thing I can do is, like, let's say if I want to find C, I could do B minus X squared plus H squared is equal to C squared, right? Just Pythagorean theorem. Or if I want to find A, right, I can do X squared plus H squared equals A squared. So that's going to be anything new for us at this point. Now I can rewrite this, so I can get C squared minus B minus X squared is equal to H squared, and also H squared is equal to A squared minus X squared. So kind of fairly similar start to for our law of sines, and now that we have H squared and H squared, we can set these equal to each other. So I can say this is C squared minus B minus X squared is equal to A squared minus X squared. Okay, so at this point it should hopefully feel pretty straightforward. And so let's kind of expand this section of the B minus X squared. So this would be C squared minus b squared minus 2bx plus x squared is equal to a squared minus x squared. And so if I distribute now this negative, right, I can write this as c squared plus b squared, pardon me, c squared minus b squared plus 2bx minus x squared is equal to a squared minus x squared. Okay. So now a question we might want to ask ourselves, though, before we go a little further is, what does x equal? So by trying to help us figure out what x is equal to, it can help us to further this equation along. Well, x in our triangle we see as the bottom of our triangle on the right. And so we can use a cosine, right? So we can use maybe a cos of c, and well, when we're done with cosine, right, that's adjacent over hypotenuse, so this is adjacent, or x, over our hypotenuse of a. So we can then rewrite this as a cos of c is equal to x. Okay, so now we have a definition for x. So now what I can do is I can what I'm going to do is I'm going to add I'm going to move all of this over to the other side so that I get c squared by itself. So I get c squared is equal to a squared plus b squared minus 2bx plus x squared minus x squared. And so, right, so we got an x squared and x squared. So when I add this x squared to both sides, these now cancel out. And so now I can rewrite this as c squared equals a squared plus b squared minus 2b to the x. And we see, well, x is also this. And so, kind of finalize, I can say c squared is equal to a squared plus b squared minus 2ba cos of c. And oftentimes you might see that a and b switched when it's written out in final form. So in final form, this is known as the law of cosine. And this law of cosine now allows us to solve any missing for those other cases. So if we have a couple sides and an angle, we can now solve using this, or maybe we're trying to find a missing side length, and we can find that missing side length using the law of cosines. Now there's different ways you might see this written out. You might see this written as a squared equals b squared plus c squared minus 2bc cos of a. You may also see it written as b squared equals a squared plus c squared minus 2ac cos of b. And finally, kind of what we already saw was c squared equals a squared plus b squared minus 2ab cos of c. And all of this, nicely put, is now what we call a law of cosine. Right? And so this is just this equation just rewritten in a slightly different order, but all the pieces are there. The negatives are in the same spot. The positives are, if the parameter is positive, it stays positive. Just rewritten a little different. So this is the law of cosines. Great help for many things, and hopefully this will help you out a lot for the lesson today, and it should hopefully speed along those problems, and then with your leftover time you can work on some homework. Look forward to seeing you guys tomorrow, and have a great day.